Welcome to the first lesson for MCT4C. I will be your host and your guide through this whole experience. We're first going to start with Unit 1 being exponential functions, but before we get there, we're going to review some necessary skills. And here's our goal for today. We want to make sure that you remember how to differentiate between a function versus a relation. So let me just underline that here, function and relations. We want to make sure you remember how to use function notation, what it looks like and why we use it, as well as state, domain, and range for a given graph. Okay, so let's get started. A function versus a relation. First of all, a function is a relationship where each input or each value of x only has one matching y value. Versus a relationship, you can have any number of y values for a given x value. So we'll summarize that and we'll give you some pictures to go with that. So I've written in our definitions here for function and relation, and I'm going to do a couple of pictures here so that we can actually see, because for me, I'm a visual person, and pictures help me really kind of understand what's going on with this. So when we were in grade 9, we talked about linear functions or linear relationships. So for example, we had y equals x plus 3. Okay, y equals x plus 3, so that's a slope of 1. Positive slope means the line's going up to the right, and a plus 3 is our y-intercept. So there's our linear function. We called it a linear relation, but it actually is a special relationship called a function. So all relations can have an infinite number of y's that match with an x, but for a function, every value of x can only have one matching y. So this particular line, and most lines, are actually functions. The only kind of line that's not a function would be your vertical line, because when you pick a value, let's say x was positive 3, to be vertical, it's going to have an infinite number of y's that match that x coordinate of 3. So it isn't a function, but every other line is. When we got to grade 10, we started talking about parabolas. So let's say we had y equals x squared, take away 3. And I should have done it in a different color, but here we go. I'll change it to red now. So that could be the parabola. Just hold on a second. I'm going to go back and make a new set of axes so that we don't get too confused here. All right, so our parabola y-intercept is negative 3, and opening up, it's a positive lead coefficient. That is also a function. So there's this thing called the vertical line test, and what it says is if I could draw a vertical line and run it from left to right, and if at any time it is only crossing one spot on the graph, then it is a function. It's called the vertical line test. Okay, and we have talked about that in the past, so hopefully you remember what that's all about. If not, ask for more clarification on that. Just keep that in mind as a way to check for a graph. Now, a relationship. We have relations that are not functions. So for example, in grade 10, oh, that's interesting. That's okay, let's go with it. In grade 10, we talked a very brief time about a circle with a center at 0, 0. That is not a function. So for example, if I had this particular x value here, if I drew a vertical line at that value of x, let me do that in a different color, you will see that it's actually going to cross the relationship twice. So that for that particular value of x, there's two different y values. So that does not pass what we call the vertical line test, and therefore that's not a function. So there's a circle, so that could be the equation x squared plus y squared equals 25. Let's say circle center 0, 0. All right, let's draw another one. Now this one I'm not going to, I can give you the equation for it. I'll do another one here. Let's say I have a sideways parabola. Okay, looks like that. That equation could be x is equal to y squared. And if I try to draw a vertical line here, again, it's going to cross the graph twice in two spots. So for that particular value of x, whatever that happens to be, there are two values of y that match it. So those are not they're not functions, those are just relationships. Okay, so hopefully that makes sense. Let's move on to function notation. I'm going to go to the next slide for that. There we go. So function notation is just a device that we use to communicate. And what we talked about back in grade 11 is that where we had, let me just undo that for a second, where we had like y is equal to x plus 3, so we had that on the last graph, we just replaced that y became f at x. Okay, f at x is equal to x plus 3. So the y just became this f at x. It doesn't mean f times a value of x. The f stands for the word function, and then if we have different functions, we just use different letters. And then this tells us the value of the independent variable. That's supposed to say value of the independent variable. And I'm not so awesome at writing on this thing, but not too bad. Okay, so for example, back in the day, we might have said if x equals 2, then y will equal 2 plus 3. So I'm subbing in the 2 for the x, and that gives us y equaling 5. With function notation, what that allows us to do is we then could write f, the value of the function, at 2, so it's telling us that we're subbing 2 in, would be equal to 2 plus 3, so f at 2 is equal to 5. So this in itself is a communication device. This is telling us that the ordered pair, the coordinate for that particular point, has an x coordinate of 2 and the y coordinate is 5. Remember, this just says y. That whole thing is y equals 5. So when x is 2, our y is 5. So a communication device to help us through that. So in summary, the nice thing about function notation is it allows us to give the function an actual name to distinguish it from other functions. So in this case, we called it f at x. But let's say we had y is equal to x squared, take away 3. So we have y here and we have y here. It gets a little confusing. We would have to give that a subscript of y1 and maybe this a y2. But we could just say now that, let's call this one g at x. So g at x is equal to the x squared, take away 3. Okay, so it allows us to give different functions different names. We have one called f, one called g. And the other thing it allows us to do is to communicate what the value of the independent variable is. And from there, we can get an actual ordered pair. Also, remember how to substitute values in, and I've already demonstrated that, but let's say we take this g at x, and I want to evaluate g at -1. So that's telling me what is the value of y when x is equal to -1. So where we have x, we replace it with -1, and then we just evaluate that. So -1 times -1 is +1, take away 3, that's going to equal -2. So that gives us an ordered pair that of -1, -2. So when x equals -1, y equals -2.